Hello guys, very welcome to my YouTube channel. In this video I am going to talk about remote LFA or RLFA, also we know it as. If you have not seen my previous video on the classic loop free alternate, then I would suggest you go to my channel and check out for that video. I'll put the link in the description as well. That video talks about how the classic LFA works. Now with the classic LFA we have a problem. For example, let's say that a link between R1 and R5 has broken. Now in ideal world, in perfect world, I calculate the path and I install that path in data plane as quickly as possible with LFA running. We know that our backup path would go through R2, right? So we send the packet to R2, and in the perfect world the packet would go to R3, R4, R5 because all of those routers have converged and they have the right information about the network that the failure has occurred and there is no link between R1 and R5 active. But the world is not perfect, right? There is a chance that R2, R3, R4, R5, any of those routers are still converging. They are stuck in some state or anything like that, right? So there can be a possibility. Suppose R2 has not converged. So in that case, R2 would think that the best path to reach to R5 is still towards R1. Then if R1 sends any packet to R2, R2 is going to send it back to R1 saying that, hey, what are you doing? You are the best person from where I have learned that information. Why are you sending the packet to me? I'll send the packet back to you. You take care of this communication. This is the looping scenario which is mitigated with the help of remote LFA or RLFA. Now, in order to make it work, we'll have to identify a router which will not send the packet back to me, right? So without thinking much on this network, you would be able to guess that if I send the packet directly to R4, via some tunnel or something, then R4 would not be sending packet back to me because the only best path for that particular prefix which is connected to R5, that best path is learnt on R4 only by R5. It is not learnt by R3 or R2 or R1 in any case, right? So this is R4 is the router in this case, which is the best router for me to send the packet directly. But can that router be R3 also? That is what we are going to figure out in my next slide, where I would discuss the mechanism that how RLFA picks the node where to send the packet directly. So let's go to the next slide now. Here I am picking the example from my previous video itself, where 4 routers were there and R1, R2, R3, R4 were connected in this manner, and the link between R1 and R2 is broken. So I'll have to identify that which is the alternate path in this network and which is the router where R1 should be sending the packet and that router would not return the packet back to R1. So I am trying to find the remote loop free alternate path here. So in order to do that, the mechanism which is followed is with the help of shortest path tree, we try to identify the router which will not send the packet back to me. So for that, we create 2 shortest path tree. First, I'll keep the R2 as a root node and I'll try to identify the nodes where R1 can reach without using the link which is failed. In this SPT, you can see that if I don't use the link between R1 and R2, which is broken, I'll prune that link. The term is called pruning in SPT, so you need to keep that in mind. So if I prune that particular link, the R1 router would still be able to reach to R4 and R3 router, right? If I prune this link, R1 can still reach to R4 and can still reach to R3 router. So this particular space where R1 can reach after pruning the link, this link is called, or this space is called P space. This is again the terminology. You don't need to put a lot of mind into it. You can just remember it as a P space. This is the space where R1 can reach after pruning the link which is broken. Now we create another SPT where I'll keep the R1 as a root node and try to see that which are the nodes R2 can reach without using the pruned link or the link which is connecting R1 and R2. So R2 can reach to R3 and R4 if we prune the link between R1 and R2, and that space is called Q space. So this is again the terminology. You don't need to put a lot of mind into it. Now we have a P space, we have a Q space. Now the routers which are our routers, the routers which we are looking for to send the packet, and those would not send the packet back to me, are the ones which comes in the intersection point of P and Q space. So here you can see that if we intersect P and Q space, we get R3 and R4 routers. Let's try to identify if this is giving me the right loop free network. I'll grab the laser pointer here. If we have a prefix which is learned on R2, suppose there is a network connected to R2 and we have a prefix called 192.168.10.0 which is learned on R2, and R2 is publishing that prefix all across the network, and every router knows that R2 is holding 192.168.10.0. Now if this particular link fails between R1 and R2, R1 will have to send the packet to R4 or R3 because those are the intersection points. Now if I send the packet to R4, let's see, R4 is learning about 192.168.10.0 via R3 and also via R1, and R1 and R3 are learning it from where? From R2. So the path taken to reach that prefix to R4 via R1 and also via R3 is equidistant. That means it is ECMP path. So R4 has an ECMP path to 192.168.10.0 prefix via R3 and R1. So if R1 sends the packet to R4 for that prefix, which is residing on R2, the R4 may or may not return the packet back to R1, right? Because it has ECMP path, equicost distance path. So if it is doing load balancing, it will send half of the packet here, half of the packet here, and there is a chance that packet would get back to R1, correct? So what is the best router in this case for me? The best router in this case for me is R3, and that is precisely the router which will be selected when we are doing P intersection Q, and we are trying to find a router where we can create a tunnel and send the packet directly. So what will happen basically is R1 will form one MPLS, targeted MPLS session with R3, and it will add one specific label to that particular targeted LDP session and send the packet to R3. Now R3 would send the packet to R2. This is what the path looks like. Now let's see this particular concept in configuration. So let me quickly introduce the network to you. First of all, I have this R1, R2, R4 routers, which are IOS-XE router, and I also have one IOS-XR router, which is XR1 router. All of these routers are having loopbacks signed. Like R1 is having 1111, R2 is having 2222, and so on. Our XR1 router has the loopback as 5555 assigned to it. Now with the help of those loopbacks, I am going to verify the connectivities and show you how the remote LFA is working. Remote LFA to work, you need to have MPLS LDP established. So here in this network, I have ISIS configured and I also have MPLS configured. Now as soon as I put the RLFA configuration, what it will do is it will try to identify those intersection point routers, PQ space router, and then it will establish a directed or targeted LDP session with those routers, and that's what we are going to see now. So for example, let me move to one of the XE routers, show run section router IS. If I do, you can see that I have already configured it, fast reroute remote LFA level 1 MPLS LDP, which I am going to use. So what I'm assuming is the network has already converged. It has identified all those intersection point routers. So it should be having some targeted LDP sessions established also. So let's see, show MPLS. If I do show MPLS LDP neighbor, I should be seeing targeted LDP sessions. For example, this is R1. So with R2, I expect, because R2 is just a neighbor. With XR5, I expect, because XR5 is also a directly connected neighbor. So these two are directly connected devices, so they will be forming a neighborship. But what about R4, this particular neighbor? Look at this. This says that this is actually a targeted LDP session, and the targeted hello is sent between 1111 and 4444. So this is the router 4, and I have one targeted LDP session with router 4. Now let's see which particular prefixes are taking advantage of this LDP session. So if I do show IP route, for example, let's try to see if the link between R1 and R2 fails. So how R1 would be able to reach to let's say 2222. If I do 2222 is which is router R2, by the way, I have one primary path which is going via gig 1, and this gig 1 will be broken. So this path will not be present in case of failure, and the repair path which I have is it is going via R4, which is 4444, and I am using MPLS remote LFA for this particular communication. Now let's see the configuration on XR device also. If you do show run router IS, this router is also having IS and MPLS LDP configured, and for LFA you just need to put the command fast-reroute per prefix, and you can choose per link also. That totally depends on you. Remote LFA, then the tunnel is using MPLS LDP, targeted LDP to be formed. And for this one also, if you do show route for suppose the link between XR1 and R1 is failing, so how I would reach to 1111? Let's see. We should be having a primary path which is also a protected path, and we have one more route which is called remote LFA or backup path, and it is going directly to repair node which is 2222. So this also explains our 50-50 theory. We know that in this case XR1 could send traffic to R4. R4 is having equidistance from both of the sides. Even if it is taking gig 3 as exit interface, it has one node to reach to R1 prefix, or if it is using gig 2 to exit out, then also it will have to cross only one node, and both the paths are ECMP paths. So there can be a chance that R4 would still send the traffic towards XR1 even if the link between the XR1 and the R1 router is broken. So R4 would not be chosen in this case. The node which is being chosen is R2 node, and there is no way that R2 would return the traffic back. Also, in few situations you may need to enable MPLS targeted LDP also. On these Cisco routers I have not done it specifically because it is already enabled by default. So in case you need to do it, you will have to configure MPLS LDP discovery, then targeted hello accept. That is all. You can put the access list also and associate it with this particular command, but that is not really needed. So I think this is enough to get started. If you want to practice it, you can just pick the notes and start practicing with this particular knowledge. I would really like to thank you for watching this video, and please like, subscribe and share to support the channel. Happy learning and have a nice day.